The last lesson in Module 12 is the lesson 10, that is perpendiculars and distance. The learning objectives of this lesson are to use perpendicular lines to find the distance between a point and a line, and then to find the distance between parallel lines using perpendicular distance. We will move on to the first objective, but before that we will see the keywords: perpendicular, equidistance. Sorry. Perpendicular lines are the ones which will make 90-degree, and equidistance means equal distance at every point. We will come to that in a while. Distance between a point and a line. Now over here, look at this particular line and this point over here, C. This is a line AB. Now you can draw infinite number of lines from this point to this line, say like this. You can keep on drawing straight lines. Okay, mine are very crooked, but I hope you're getting the point. You can draw any number of lines. Now, but that can be only one particular line which will be the least distance. That is, if I draw any line, okay, say this one. Imagine this will be about 5.6 centimeter. Over here, I might get about 5.7, or there might be one line over here, 5.1. Similarly, you can each lines you draw will be at different distances from this point, right? But there will be only one particular line which will be the least distance. That means less distance compared to all. That will be the perpendicular line. So whenever this line is perpendicular to this point, then that will be the lowest distant line. So that is what it says basically over here. And now we will see over here the perpendicular postulate. Now, if a line, we have already done in the previous lesson about parallel lines, right? Similarly, we have perpendicular postulate. Now, if a line is given to a point which is not on the line, then there is exactly only one point which will be perpendicular. That means if this is a point and this is a line, only one particular line will be perpendicular. You can't draw two lines or so. Same way it was the same, sorry, let me just go back. It was similarly for the parallel lines as well. Only one line can be exactly parallel to the given line from that point. Now then, we will solve some problems. Line L contains points 1, 2 and 5, 4. You can see over here in this line. Find the distance between line L and the point 1, 7. When they mean distance, we need to find the shortest distance or the perpendicular distance. Now, how do we do that? First, we need to find the equation of this particular line. We have 2 points. It is easy to find the slope. Slope is, we have already done these steps beforehand. So if you're coming just to this lesson, I would request you to go back to the previous lessons, be thorough, and then move on to this lesson. Now, yes, slope formula y2 minus y1 divided by x2 minus x1. We have already done it. We can consider this as x1, sorry, x1, y1, x2, y2. Now, we here just substitute this in the formula. 4 minus 2 divided by 5 minus 1. You will get the answer half. That is 0.5. Then you can use any of these points. You can use this point or this point to find the intercept. We have done this before as well to find the intercept. Now it's up to you to choose. Over here they have used 1, 2, and you can solve and find the y-intercept, the b value. But I will use this point and I will get the same answer. I will just show it over here. So what is the y value in this case? X and y. So the y is 4. That is equal to, the slope is 0.5 times x. What is x value? It is 5 plus b. So all you need to do is b equals 4 minus half of 5 is 2.5. So now 4 minus 2.5 is 1.5. You can do this in calculator or by solving. You use this point or this point, the answer will not change because it's the same line, the same point, the same slope. So this is the thing. Now you found the b value, that is the y-intercept. Now use the same slope-intercept equation to write the equation. The slope is 0.5x plus 1.5 the y-intercept. Now write an equation for the line perpendicular to it. How would you find the slope for this line? We know this point, we need to find a line which is perpendicular, right? Use the slope criteria or the slope relationship. We know if two lines are perpendicular, when you multiply the two slopes, it must be -1. Now multiply zero point 0.5 with the slope of the perpendicular line, it must be -1. So this is how we can easily get the slope of the other line, that will be -2. So it is basically half m2, that is the slope of the perpendicular line, equals -1. 0 point is half. 2 goes to the other side. m2 is equal to -2. That's it. Now, what is the next thing? Same thing what we have done over here. Find the intercept using these 2 points. Plug in the values over here. Y is 7, x is 1. Solve it. And the slope is -2 over here. Solve it for b. Directly it will be -2. When it goes to the other side, it will be +2. 7 plus 2 is 9. And the answer is b equals 9. Now you can write the equation. That is -2x plus 9. So we got the equation for this perpendicular line and this this line over here. So what else? We need to find the distance, isn't it? Distance. That means I need to know. So let me just draw that line. I need to know the distance from here to here. Okay. To find the distance, we have a simple distance formula. We have done this before, distance in the last term. But before the distance formula, I need a point over here, the point of intersection. How will I find the point of intersection with this line and this line? It is very simple. If you equate these both equation, you will get the intersection point. Now, if I have this line and one more line, okay? If I want to find this point of intersection, I need to make these two lines equal, equate them. There are many ways to solve these, or just get it in terms of this equation, ax plus by equals c. Get them both in this form and then solve it in calculator. It's up to you. So now we will use the calculator method because that's very easy over here to solve. All you need to do is write in the standard form, that is ax plus by equals c. What you need to do is the two equations are there, right? Take the x to the other side. What happens? See, you found the two equations, that is one this line and one more line that's perpendicular. All you need to do now is write them in the standard form. What did I do over here? The 0 0.5 goes to the other side, becomes minus 0.5x plus y equals 1.5. Similarly, the next line, the perpendicular line, take the minus 2x to the other side and becomes plus 2x plus y equals 9. All you need to do is use the calculator, mod phi, and this is the first standard form. See, this is the standard form, right? Equation 1. Now put in all the coefficients, minus 0 0.5, the coefficient of y is 1, and 1.5. And over here we have 2, 1, and 9. That is it. Now what do we do? Press equal to. The x value is 3, y value is 3. If you are doing the written method, what happens is it's easy, but you need to do it's a long method, that's it. But in the calculator, it's very simple. Now we got the point of intersection between these two lines as 3, 3. So this is the thing. We now know the points of intersection is 3, 3. We can call it as q, p and q. So this and this over here, 3 and 3, this is the point, that's the q. So that would be the shortest distance. So now we need to find the distance between these 2 points. You know the coordinates, just use the distance formula, that is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Substitute it and you will get the answer. Take the initial point as x1, y1, x2 over here it's 3, 3, x2 y2. Now all you need to do is substitute over here. X2 is 3 minus x1 is 1. Same way, y2 is 3 minus 7. And you will get the answer root 20. This is how easy it is. Now we will see one more problem. I hope this is clear. All you need to do is find the distance, but from where this point and the intersection point. Let's do another problem quickly. So the distance of root 20 is 4.47. Now let us see over here in the next problem. The developers of an amusement park want to build a new attraction. According to the park regulation, the entrance to each attraction must be at least 10 yards from the center of the main street. In the design plans, the entrance of the new attraction is located at this particular point. The main street over here contains the points 1 and 11 comma minus 9. If each unit represents 1 yard, will the new attraction comply with the regulation? Now, what is the regulation? It must be at least 10 yards from the center of the main street. So, if this has to be over here, this attraction has to be at this point, it must be the distance from here to here, the shortest distance must be 10 yards. So basically, whatever we just now did, find the equation of this line, find the equation of the perpendicular line, and then solve it and make sure it must be more than 10. If it's more than 10, you should tell yes, it complies, otherwise no. I would ask you to pause the video now and try to solve this yourself. I hope you at least tried it. And now we will see the answers together. It is very simple. Now, first thing, over here we have 2 points. Use the slope formula. x1, y1, x2, y2. Use it. y2 minus y1, x2 minus x1. You will get the answer of the slope. Now, over here, you can use any point. We checked for both point to find the intercept. Even if you use this point, you'll get the same answer. We use the slope intercept form. Substitute x and y value and the slope value. Find the intercept. And then write the equation. That is minus 1x plus 2. Now, next would be to find the slope of the parallel line. We know perpendicular line. Perpendicular lines are, when you multiply the slope, it must be minus 1. So all you need to do is multiply them and get the answer. You will get 1 because negative cancels. What next? Very simple. Use the point of intersection over here to find the b value intercept. Same way, just like what we have done. Now substitute over here, solve it and get the answer of y-intercept. Write the equation. We have both the equations. Now you can use your calculator and solve it. Look at the first equation, second equation. Just write x and y together and then mod phi 1. Plug in the values of coefficients. And over here it is minus 1, 1 and minus 4. You will get the intersection points 3 and minus 1. X is 3, y is minus 1. We got the same answers. Now all you need to do is find the distance between this point A and this one over here. Let's see the distance of, say over here you can see A and this point. x1, y1, x2, y2. All you need to do is put it in the calculator. In the distance formula, calculator, you will get the answer. That is 12.73. Now, very important. This is located far enough. Yes, because it's more than 10. It's more than 10. Sorry, this is more than 10. Therefore, yes, it is far enough to be located and it will comply the regulations. So please go make sure you remember the distance formula and the perpendicular line, and also to solve the equations to find the intersection point. Now we will see how we can find the distance between parallel lines. You can see over here L and M are parallel lines. How do we find the exact distance between them? So you need to consider any of this line. It's up to you. I will choose this line M. Okay. You need to find the perpendicular distance from this line, to any of the point in the other line. It must be perpendicular. So now what it means is you do not need to find 2 points of the lines and something like that. No. First, if you choose this line M, use this particular line, find a perpendicular line to this line, perpendicular line, okay? So using any point, you can find a perpendicular line. Then you need to find the intersecting point with this line and then find the distance between these 2 points. Anyway, it sounds hard, it sounds confusing to be honest. We will do a problem, you'll understand how to do it. So before we go ahead, let's see this. Two lines equidistant from third. In a plane, if two lines are equidistant from a third line, that means if the distance between these two lines, say, is 2 and 2 over here as well, then those two lines are parallel to each other. Okay, why? Because they're all in the same distance apart, so then they are parallel. Now over here, that is what it means. Now these are the two lines, right? Over here, if the W is equidistant from X and V is equidistant from X over here, if the distance is same, then they are parallel. So that is the thing. Now let us see this problem. Distance between parallel lines. Find the distance between the parallel lines R and T. Over here, the diagram is not accurate, but since the slopes are negative, we can consider this to be the diagram. Let's consider this is R and this is T. With the equations, y equals minus 3x minus 5 and y equals minus 3x plus 6. Now look over here. If they are parallel lines, the slopes must be same and the intercepts must be different. Yes, absolutely. In these two equations, you can see the slope is minus 3 of both the parallel lines and the y-intercept is different. Yes, they are parallel. So now we need to find the distance between them. So now what we need to do is find the equation of the perpendicular line. We need to know the perpendicular line now. So we need a perpendicular line, say anything, Q or anything. So then we can find the distance between the parallel lines. Now over here, we can consider any one equation. Now this is important because now you will consider any one of the equation. Then if we consider this, say the line R, then we won't use the intersecting point for this line. We have to use the other equation later on. So for now, time being, we will just consider the first equation over here. I'll just double check. Yes, the first equation is considered. So now what we will do is find the slope of the perpendicular line for this. We know the slope of perpendicular lines will be -1 when you product of the slopes of the perpendicular line are -1. So I'm considering this line and I will find a perpendicular line for this particular equation or this line equation. So now I have this line, so I will find the perpendicular from this, originating from this. So what do we do? First find the slope of the perpendicular line. Multiply minus 3 times the slope of the perpendicular line equals -1. Negative negative cancels and it will be 1 by 3. Okay, that is the slope of the perpendicular line. Now you need to consider any one of the equations. So we have considered the first equation, and now let us find any coordinate. The easiest of all coordinate is assume x to be 0. Assume this x to be 0. Okay, what is the y value when x is 0? Put over here 0. What is the y value? Minus 3 minus 0, it's all 0, gone. What is the y value remaining? Minus 5. So why it is easy to take x is equal to 0? Because whenever you want to find the coordinates of this at x is equal to 0, what is the coordinate? Remove this term because 0 makes it 0, right? Answer is 6 in this case. In this it is minus 5. Okay. Now we are just focusing on the first equation. X is 0 and y is minus 5. Now use these points. So now basically what happens is I will consider this line, okay? And this particular point is the point where I have my perpendicular line. So these points is shared by the perpendicular line as well. So I will use these particular points to find the equation for the perpendicular line. Now, how do we find the y-intercept? Use these points over here. x is 0, y is minus 5. Solve it. You will get the b value to be minus 5. And now I can write the equation of the perpendicular line. So the perpendicular line equation is y equals, the slope is 1 by 3x minus 5. I hope this much is clear. Now all we know is there is a perpendicular line having this particular equation. Okay, and to find the perpendicular line we have used this particular equation. So we know this much now. This, imagine this is the line, parallel line, one of the parallel line. We now know the perpendicular line. We know the equation of this and this. We know there is a other parallel line as well. Now the important thing is distance. Now this equation is used to originate the perpendicular line. Now you need to find the intersection. See the intersection between this perpendicular line and the other parallel line. So find the intersection between this perpendicular and this parallel. It is similar to what we have done in the previous video, the previous problem. Let's see now how we do that. We need to find, okay, I will tell you what this exactly means. Now we had used this particular equation already, right? So leave that. So other parallel line is considered to find the intersection point, because now this much is there. Now to find the intersection point, we need the equation of this and the perpendicular line and solve it, and you will get the intersection over here. So use the other line. See, y is equal to minus 3x plus 6. This step was done in the last video as well, last type of problem. So use this particular line, rearrange it and write it as 3xy plus x plus y equals c. 3x plus y, this 3 minus 3 becomes plus 3x plus y equals 6. What about the other one, y? This equation. This is the perpendicular line equation. Now, minus 1 by 3x plus y equals negative 5. So now all you need to do is go to mode 5 and 1 and now substitute them. 3, 1, 6. And sorry, I have not typed the other equation, so obviously it will be infinite. Okay, over here, minus 1 divided by 3, 1 and minus 5. So what are the answers? We are getting 3.3 and 3.9. So these are the intersecting points. I will tell again, we had used this particular equation as the base and we formed a perpendicular line. So we used the details of this equation to find the perpendicular line equation. So we found the perpendicular line equation. Now there is one more parallel line. See, this and this are parallel. So I'll write P over here. Sorry, PA parallel, PA parallel. So now we know these both, but we already used this particular equation, PA1. This is better, and this is PA2. So we used PA1 to find the equation of this perpendicular line. So we use that to find the equation of the perpendicular line. So now we use PA2 to find the intersecting point over here, this any point, okay? Because the distance between parallel lines is the perpendicular from any one of the parallel line and the point of another line, point, okay? So now how do we find this point is we equate the equations of this PA2 and perpendicular line PER. Okay, so that is what we have done. We are done equating these both. So make in terms of x plus y equals c. Get in terms of this, say x plus y equals c. Over here also x plus y equals c for the perpendicular line. And when we solve, we get the intersecting point. So now we got this intersecting point. Okay. Do you remember which point over here was considered? We had considered one point. I had told take x is 0 and the y was minus 5. So we know over here the perpendicular line touches the initial line at 0 comma minus 5. And what about this? We just now solved now. It is 3.3, sorry. 3.3 comma minus 3.9. So now we know both the intersecting point. I'll just show you where is the 0.0 comma minus 5. See over here. We had considered this, right? That is very crucial for now, because now we know the two intersecting points. If we find the distance between 0 comma minus 5 and 3 comma 3, we will get the perpendicular distance. Let us do it now. The intersecting points, that is 0 comma minus 5 and 3.3 comma 3.3 and minus 3.9. Find the distance. Over here, x1, y1, x2, y2. Find this distance between them. And over here, you will get the answer 3.48 units. So the distance between the parallel lines of these two equations is, 3.48 units. That is the answer for this question. So that is how we solve this particular lesson. Few things to remember: equations of parallel or perpendicular lines, solving the equations using calculator to find the intersecting point, and the distance formula. And then you can easily solve it. So we have come to the end of this lesson. Please write your doubts or any queries in the comment section, and I will get back to you as soon as possible. Thank you very much.